So what I want to touch on is how do we do the making of functions as well as making graphs in Mathcad 15. So that's what we're going to touch on right now. You might remember this problem from a few days ago. We aren't going to try to do the whole thing. What I've decided to do is pick off one little part of the problem in order to demonstrate these ideas. Okay? So you might remember when we did this problem earlier, one of the things that we needed to do was figure out what the length was of segment BD, which is basically the length of the spring. We needed to figure out what that length was in terms of theta and make a function for that. Okay? Do you remember how we did that? Okay, we used the law of cosines, right? And the law of cosines basically is kind of like the Pythagorean theorem, but it's a little bit more powerful than the Pythagorean theorem. And so the function that we came up with was that the length BD as a function of theta, okay, so what we do there is we open up a parenthesis and put in the variable that we were trying to use, theta, okay, and what was next, do you remember? Square root of, and then we did what? Okay, we took the two lengths of the sides that we knew, so we have LAD, for instance, and we did what? Squared it. We added LAB, and we square that. Okay, then what? Minus 2 LAB times LAD times cosine of theta. Okay? And you might remember the little technique I showed y'all last time about how you can sort of set a test value to kind of check it out and see if it's working. So I did that already up here, calling it theta sub test. So if I want to, I can ask for this function to report to me what would its output be if I plugged in that test value. And I do that with the evaluation operator, which is a plain equals sign. Okay? Now, I started this problem with units of inches. It might be more relatable to me if I go back 2 inches for what it shows me there. Okay? And that seems like it might make sense. We can try out a couple of values that we might know what the correct answer should be, right? Since we know that segment AB is 4 inches long, if theta is at 0 degrees, it makes sense that the spring would have to make up the difference for the 15 inches, and so it makes sense that it would be 11 inches, or I could put this at 180 degrees for another value to kind of check it out and make sure that it looks like it's working. So, looks like that much is working so far. Okay. And what I'm trying to do here is actually come up with a chart that gives me 2 different things. I want to get a graph that gives me both length BD as well as angle phi, both of them in terms of theta. And I'm going to put both of those on one plot. Okay? So, how do I go now and compute angle phi? Well, we might go back and remember the law of sines. Right? The sine of what? Phi. Okay, over LAB is the same as sine of theta over what? LBD, and that is a function of theta. Okay, so that's the basic equation that we will use. If we want to rearrange that so that we get out just phi, okay, what we do is we take phi and express it as a function of theta. Okay, what would the first operation be? Okay, arcsine of, okay, LAB times sine of theta over LBD of theta. Okay, and I can kind of check this one out too if I want, and have it return to me a phi value for a test case of theta. All right. And at 180 degrees, it makes sense to me that it would return 0. What happens if I go to something, let's say, like 80 degrees? Well, you see there, what's the value that it's giving me? What are those units? Radians, right? So I need to take this, if I want to make it, again, a more relatable value to, things that we're used to seeing, we can change that to degrees, for instance. All right, so that's kind of review, because that much of it, we already kind of touched on how to do those things. The other thing that I'll mention before I move on is do note that we are using a function inside of the definition of another function. So it's important to realize that we can stack these functions in that way. You can call another function within a function, all right, as long as that function appeared before it in the sheet. All right, so what we want to do with these is we want to actually make a plot that gives us both LBD as well as phi as functions of theta. So I'm going to insert a graph, and inside of there you'll see an XY plot is one of the options that you can insert. Okay, those of you who are trying to follow along in Mathcad Prime, these steps are very different for Mathcad Prime relative to Mathcad 15. This is actually one of the reasons why I personally prefer Mathcad 15 significantly over Mathcad Prime. All right, so what do you think we want to do on the horizontal axis? That's our independent variable, right? So we want to put theta down there. And this is probably the thing that makes some people dislike using Mathcad 15, because this next step I'm about to do doesn't make a lot of sense to some people. But if you actually think about it, it makes a lot of mathematical sense. If I want that axis to show up in values of degrees, what do you think I should do here? Okay, you might want to type degrees afterward, but that's actually not what you want to do. What you want to do is divide by what you would like to see. Okay, if you think about this, this makes sense. So imagine that theta is a value that has units associated with, and those units are degrees, right? What you actually want to show up on this plot are just numbers, right? So you want to get rid of the degrees that's by nature attached to that variable when it comes into this. And to get rid of the units that are already attached to it, you can divide by the type of unit that you would like to see. All right? This is counterintuitive to some people, but the more you think about it, the more it actually makes sense mathematically that this is what you should do. Okay? So that's what we want to put there. What do you think you put up here? Your function. Okay? I'll put in LBD as a function of theta. Okay? If I just leave it like that, what do you think is going to show up? So what it typically does is it goes back to the default units for length that are built into this sheet. So if I don't do anything, what it will probably show me is numbers that are associated with meters, probably, since the units that are attached to that number are length. It'll probably show it to me in meters. That's not really what I want. All right, so what should I do? Okay, divide by the units I'd like to see. All right. And that creates a plot. Is that what we want? Do all values of theta make equal sense for this problem? Not really, right? Where does it make sense, like, mostly? Starting at 0, going to 180. Okay, and what you're doing for setting these limits on this axis down here, you are setting those limits as numbers that are associated with the variable with the units that you'd like to see, right? And then you just put it in like 0 to 180, and that gives you this plot for the length of BD in inches going from 0 to 180 degrees. Okay, it's pretty cool, huh? All right. You can do the same thing. I didn't do it yet on the vertical axis, but you can do the same thing if you want and set what the limits are for the vertical axis. It will, by default, it will take its best guess at what it thinks those limits should be, but if you don't like them, you can go in and change them just by typing on these placeholders. Okay? All right, but I said what we wanted to do was to put in two different charts, all right, two different plots. What's the other plot that I said we wanted to put in? Okay. We want to put in phi of theta, which is the other angle opposite of where theta is. Okay. To do that, what we're going to do is right-click on the chart and go to Format. Okay. And inside Format, you might see up here, we can enable a secondary y-axis. Okay. There's a whole bunch of other stuff in this dialog box as well. I'm going to come back to it in just a second and show you some of those. So what did it just give me? It gave me another placeholder over here. What do you think I put there? Phi of theta. Again, divide by the units that I'd like to see. Okay. And what it gives me is the ability to plot two different things. In this case, I plotted them on two different axes as well. What do you think the reason was why I wanted to do it that way? Yeah, it makes it to where it makes it easier for me to have different units on the two and different ranges if I wanted to. Okay. Now for this particular problem though, the numbers themselves, as long as I use these units, the numbers themselves lie within kind of a similar range, right? So I actually could, for this one, plot both of these on the same axis, even though in general, that's more of a dubious proposition whether or not you can do that, given the numbers that you're actually using, right? If you have two dissimilar kinds of things that you're plotting on the same set of axes, a lot of times you might have to have two different y-axes like this to plot against, which is why I showed you this first. Yes, ma'am? I do not know if it's even possible in Prime. Do two plots to... Okay, I think though the way Mathcad Prime works is more like the one I'm about to show you, where I do not give it a whole other axis like this. If you go back into Format, I'm going to undo the secondary y-axis here and show you here that we can, if you select this on the left, if you're selecting the whole thing with that blue cursor, right? That's kind of important. You have to pick the entire entry for that with your blue cursor and hit comma. It gives you another placeholder where you can put another trace in. So that's another way that I can put in phi of theta. And it works, you know, it works okay for this because the values are kind of in the same range, right? But you can't always plan on that, right? So that's why I show you the two different ways of doing this. Okay. What do you think I might want this range to be? Okay, you might see there it picked something, but what it picked wasn't great. So I go in and I change it to more like what I want it to be. All right, and now I've got those two values there over on just one side. Okay, so those are the two different ways you can put them in there. I'll tell you what I'm going to do. Not to kind of mess with you too much, I'm going to go back to what I had the first time. Okay, and I'm going to go in here and again enable that secondary y-axis. Put this in here. I'm going to let this be 0. All right. The other stuff I want to show you here is some of the other formatting options that you have available to you. All right. So going into this dialog box again, there's a few basic things that you might be interested in. You can put in grid lines if you want. Okay, so that might be kind of interesting. You guys will love this color. Watch. That's a nice color. All right. What else is important? Like, you're an engineer and you have to make plots a lot of times. We spent a good bit of time whenever we studied Excel doing what with our plots? Okay, making them pretty is one way of saying it, but including the right kinds of things that are not negotiable, right? Things that you have to have on plots if you are doing nice engineering formatting on things. So what are some of those things that you have to have? Okay, some labels and a title. Okay, so maybe I'll put dimensions of moving lever. I don't know. Something like this. So you put a title that's somewhat descriptive of what you're trying to do. Okay, then what? Down on your bottom axis, you might say position angle. Okay, and you might put in there what? Units. Okay, what about your first y-axis? Length, or length of spring. Something like this, and you put in inches. And we are using our other y-axis as well, right? So we might put in here angle of spring. Something along these lines. And put in degrees for that number. Okay? And let's just see what that looks like real quick. All right? Kind of gets a little bit large here. I'm going to close down my Greek menu here for just a second so you can see that. Okay? Does that look nice and clean yet? I don't think so. Okay, I want to show you another couple things you can do in here. One of them is you can go in to, I believe it's this one here, we're under traces. All right. You can go in here and ask it to hide your arguments. What do you think that does? Okay, yeah, all these places where you put the information into the chart to make it do a certain thing, those aren't naturally formatted all that nicely, right? So you can make them go away. What do you think it does if I do uncheck the hide legend? Okay, that'll show the legend. There's also some choices about where you can put the legend. Where do you think you'd like to put it? Okay, you want it on the bottom right? Or we can leave it below. That sometimes it's nice just to leave it below. I'm just going to leave it below. Okay. Now watch what happens when I click back off of here again. Okay. So that's kind of nice, right? It's showing you a much more nicely formatted chart this way. What else would you like to do? Okay, you can change the color of the grid lines if you care to. If you want to do that, it's right in here. The grid lines. What color you want to make them? Gray. Okay, that sounds good. Do note that you can change grid lines in one direction and the other direction independently. Okay, so maybe you like those better now. Do you like this saying trace 1 and trace 2? Okay, we can change those as well. Under traces, we can go in and name these things. Okay, so you might say spring length, and you might say spring angle. Okay, what else can you do in here? You can put symbols on the lines if you want. You can change, maybe I don't like the little dots there. I'd rather have dashes. I can change the colors, right? If I want to change this, we're not using green now. We could go to green. Or we do purple. Nobody likes purple. That's not a great color. I'm going to leave it alone. All right. And there our plot is starting to look a lot better. Okay. Let me show you one other thing that you can do to control this. And it involves entering something that's called a range variable. Okay. Range variables allow you to set up exactly how many points your plot will plot. Okay? Behind the scenes for these traces that you see right here, there are actual data points that it is interpolating between. Okay? Sometimes you want to change that. You might want to have more, you might want to have less. Most of the time when I'm doing this, it's because I want more, right? So if you want to do that, what you do is you set up a variable. Since I have this whole thing defined in terms of just plain theta, I'm going to make theta my range variable. So this is kind of an optional step. I need to turn my Greek toolbar back on here. Okay. To define my range variable, I first put the variable in there and then use the assignment operator just like we were used to. What's the range you think I want for my variable? 0 to 180. So I put in 0. Okay. The next step is you put in the next value that you would like in the sequence. Okay. So let's say we want to do it every degree. Okay. So I put in 0, comma, 1 degree, and then someone says dot, 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 right? It doesn't actually do 3 dots, it does 2, but the keystroke to get that is a semicolon. All right, and you go up to the final value that you would like it to get to. Okay, and I know it didn't change look much there, but it has now set it up to where every degree I have another data point. Okay, we can really show this to ourselves. If I change this, for instance, I don't know if we'll see it at that. I'll really make it obvious here. Let's change this to like 60, right? And you can see there, it's not plotting many points now to make this chart. Okay, so go back in here and put it back to 1 to make that chart look nice. Okay. If you put too many points in there, it might sort of choke on it, right? There's a lot of data that it's crunching if you put a lot of data points in there for it to come up with, but that's how you control how many data points will actually be plotted in the chart. All right, questions? No questions? Awesome.